Question 7. There are 4 ester with molecular formula C6H12O2, which shown in this figure 7.1. Give the systematic name of ester A. Very easy. So it's a methyl. 1, 2, 3, 4, 5. So we know that it's methyl pentanoate. Part B. A mixture of these ester is analyzed by the gas liquid chromatography, and the chromatogram shown in figure 7.2. The area of each peak is proportional to the mass of the respective ester. So we have these 4 ester right in this chromatogram. Already show the percentage here, or the area, right? So this is the area. So it's 14 for C, 25 for B, 52 for A, 38 for D. Total is 129. Part 1. State what is means by retention time. So means how long the ester or the analyte or the compound it can hold by the column, means the GC column. But the definition is very easy. It's the time between the sample injection and detection. So after injection, so those ester will come out one by one. So these are all the retention time. For part 2, calculate the percentage by mass of ester D in the mixture. Very easy. You just need to use the area of D, 38, over total area, 129. So times 100%, you get 29.5%. Part C. Separate samples of these ester are analyzed in the proton and the carbon NMR. Complete table 7.1 to show the numbers of peaks in the NMR spectrum for ester B and C only. Okay, B and C, let's look at their signals. Let's start with the B. About the proton NMR, the signals, so we need to know how many types of chemicals environments in there. So this one, this proton has one environment or one chemical environment. So this one will give one signal, 2, 3, 4, 5. Because all these protons, they're having the different chemical environment, therefore it will produce 5 signals or 5 peaks there, right? Okay, so proton NMR, 5 peaks. Okay, about carbon. So for the B, now let's look at the carbon. Carbon is here 1, 2, 3, 4, 5, 6. So these carbon, they also having different chemical environment. Okay, that's why it will produce 6 peaks or 6 signals, right? As shown in this table. For C, this one you have to be careful, because for the proton, okay, so let's look at the proton here. Okay, these two proton, actually they are similar. We call equivalence proton. They're having the same chemical environment. That's why these two protons will give one signal. So 1, 2, 3, 4. Only 4. Right, 4 proton. For carbon, again, these two carbon, they're having the same chemical environment. So it gives one signal, 2, 3, 4, 5. So carbon NMR for this ester C is 5 peaks or 5 signals there. And for part 2, identify all of the ester from A, B, C, D that have at least one triplet in their proton NMR, just proton NMR. Yeah, of course it's proton NMR because triplets, quartet, and all these multiplet is from the proton NMR in your syllabus. Okay, so now you need to identify, let's compare all this, see which one will produce a triplet. Okay, so for B, let's start from B. Okay, this one, it will form triplets. Why? Because it's one, it will couple with the two protons here. So 1 plus 2, so it's form triplet. 1 plus 2 here. So it will form a triplets in the proton NMR. Of course, this one will form 1, 2, 3, 4, 5. So it will form the quintet, right? Five peaks there, right, in this signal. Okay, so therefore B, yes, B can form the triplet. How about A? So A also can, because A here is CH3. So this one will couple with this CH2. So it's 1 plus 2. So it will form triplets. Okay, this one will form multiplet. Yeah, this one will couple with these 2 hydrogen and these 3 hydrogen. Alright. So okay. However, compound A, yeah, it still can produce a triplet, right? The rest cannot. All these protons cannot. This one forms singlet. This one will form yeah, this one can. Sorry, yeah. So this one can. This one is 1 plus 2. This one also can form triplets. Okay, only this carbon and this carbon can form triplets. Okay, the rest cannot. Okay, this one will form 1 plus 2 plus 2, so it will form 5 peaks in the signals. This one only singlet. Okay, so A and B, yes, can now. How about C? C cannot. This one will form singlet. This one will form, because 1 is coupled with this hydrogen, is form doublet. And this one, this proton will form multiplet. And this one will form doublet, right? Because these 6 protons will couple with this proton to form doublets. So means all these protons cannot form triplets. Okay, how about D? D, this proton will form singlet, only itself. And this one, they are all equivalents, you know. So, and this carbon, no protons. So it cannot couple with others. So it will form singlets for all. So we just see singlets here for these 3. Okay, therefore, only A and B can form the triplet. Right, so A and B. Okay, so now question now part D. We have a compound F and K and many to go. So this question is mostly for compound F. So you need to deduce its structure. The answer I show later will follow the main mark scheme. There are quite a numbers of the possible structures to form, but I will just use the one that in the main mark scheme, right? Okay, so let's start. So compound F is a C6H8O3. Okay, shows stereoisomerism. Stereoisomerism, it could be cis trans and optical isomerism. Okay. So now another one is effervescence with the sodium carbonate. This one is telling us in the compound F is at least must have 1 COOH. In fact, it should be just 1 because 3 oxygen. 2 oxygens will use for this COOH. Okay, next. Compound F reacts with alkaline iodine to form yellow precipitate G and compound H. Yellow precipitate means this is the iodoform, and of course the H is the others products. Later we discuss. It's telling you that compound F, it must have this one, the methyl ketone, or this alcohol group. So next, compound F reacts with the lithium aluminum hydride to form compound J. So it clearly shows that one hydrogen is missing, is lost, and add 4 hydrogen. So this is the reductions of this compound F. So we know that the carboxylic acid shear will reduce. When the carboxylic acid reduce, so if you remove 1 O and add 2 H. Okay, that's how the oxygens are being removed here, right, from 3 to 2 now. And another one is it's add 2 hydrogen just now and need to add another 2 hydrogen. Means it's telling you the methyl ketone just now need to add 2 hydrogen. So this one add 1 and here add another 1 to form this alcohol, right? So we are quite sure now the in this second statement, right? So just now I told you possible to be methyl ketone or this alcohol, right? So now it cannot be this alcohol, it must be the methyl ketone because of this the molecular formula. So it's telling us that it must be 1 carboxylic acid and 1 methyl ketone, right? Now compound F reacts with SOCl2 to form a compound K. This one is quite easy. This one is when there is a carboxylic acid. So when carboxylic acid with the SOCl2, it can form the acyl chloride. This is how it should be. Carboxylic acid with SOCl2 can convert to this acyl chloride. Compound K reacts with propane 2O to form compound L. Okay, this one we discuss later. Right? Is similar to this esterification, right? To form the ester later. Okay, so now let's start. Combine all this information, so we can actually start with the structures of the compound F, because we know that now it has 1 COOH and 1 methyl ketone. So you can actually put these 2 groups at the 2 different terminals. Let's say now you put the methyl ketone on left hand side, methyl ketone. So this one C with this carbonyl, and after that you need to add the others carbon. Okay, because it has 6 carbon, no, so therefore it's 1, 2, so it's 1, 2, 3, 4. Okay, you make it 5 first, because for this one, the terminals, we need to put the carboxylic acid. Don't put a whole straight chain because it cannot form the cis trans later, right? So you need to put these another carbons. Okay, let's say if you follow the main mark scheme, so the carbon should be displaced. So you put the carbon at this place, the second carbon, the first carbon, second carbon. So there is a branch here. Okay, so this is the main skeleton of the compound F. Then you need to consider the hydrogen's number, because if you really calculate and you know, then it should be another double bond there, because only 8 hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8. If it's H10, then here there is another 2 hydrogens, right? Because now it's lack of 2 hydrogen, so it's letting us know it should be another double bond inside, right? So therefore, we can use all this information to deduce the compound F structure. It's something like this, right? This one. So once you know this structure, then you just put in the this form, the skeleton form. Actually, not necessary for you to put in skeleton form. If you want to put in this form, also can, as long as it's the correct structure, right? okay, this is the answer that's shown in the mark scheme, okay, which is the one that I told you just now. One COOH and one methyl ketone, and of course the double bonds here. Okay, now let's start with the first one. Compound F reacts with the alkaline iodine to form the yellow precipitate, and compound H. Let's move to right hand side here. So we know that this compound F, when we use the alkaline iodine, react with it, so the methyl ketone will react. Okay, how it reacts, I just tell you roughly how it works. When this methyl ketone with the iodines, alkaline iodines, first, this CH3 will convert to Ci3. So means all the H3 will substitute to I3, to means iodine. And after that, this part will undergo hydrolysis, means a bond break. And hydrolysis means is similar to the hydrolysis of ester. See? So means this part, the Ci3 will get the H, and this carbonyl will get OH. So eventually it will give the first compound, the G, the iodoform, CHI3, and this compound. So after hydrolysis, this carbonyl now form OH, COOH here. Okay, therefore this is the compound H. Now let's move on to the second statement, lithium aluminum hydride, okay, which form the compound J. Compound J is C6H12O2. So now it's quite clear. If this one is get reduced, so means carboxylic acid need to get reduced. Okay, this one remove oxygen, add 2 hydrogen, and this one double bonds break. Okay, add 1 hydrogen, add 1 hydrogen here. So therefore, it will be like remove 1 oxygen and add 4 hydrogen. So you get this J, so which is this compound, right? Okay, quite straightforward now. And for this compound F, if reacts with the SOCl2, means this part will react. It will undergo substitution. OH will substitute by chlorine to form acyl chloride. Here, only this part. And after that, this K, compound K is the last one, react with propane 2O. Propane 2O is this, yeah, right, this one. And it will undergo the condensation and form the ester, right? Okay, so this one is K, compound K, and this is a propane 2O. The Cl in the acyl chloride, of course, will combine with the hydrogens in the alcohol and form HCl, remove HCl. And the new bonds will form between the C and O here. So it will form the ester. Okay, eventually it will form this compound, right? So the ester, oh, okay, this one, there is one mistake here. Okay, no, it's not mistake. Okay, so again, this one from new bonding, yep. Okay, so remove HCl, yeah, so this one, okay, eventually it will form this ester group. Okay, and of course, if you want to draw the skeleton, then it will be something like this, right? So this is a part, so this is a part here. Right? Okay, that's all. Thank you.